All right, I was able to repopulate the drawing space and include the stringer to scale. Not that that's necessarily important that it be to scale. I can always, if I do that, I can use an architect's scale. If I forget to assign a dimension and I know the scale, I can use an architect's scale, which I haven't got on the site, but of course I own one, and I can get the dimension that I need, which is the point of a scale drawing that even says that it's to scale, which this doesn't even say. So I'm being super sloppy here. I'm just using my plotter is down, so I've got the 8.5 by 11 is the largest I can do, so I leave the title block out because it takes up too much space, yada yada. So please don't judge me by my ad hoc drawing. This is just the musical set, but you can certainly lay a stringer out in real life only, and that's what you would do. That's the thing about all of this. I've said it before. We don't plan the location of sticks in a residential construction project. Specifically, we don't, measure them up and then make them to size. That's more of a mechanical angle to take on a project. This is a finite product unit that's on wheels and rolling, and thereby I want it to be as square and as perfect as possible, so I'll bother to make everything exactly the same and mirror it around. And in a residential construction project, yes, largely the studs are all cut to the same length, the jacks for all the windows and doors are cut to the same length, etc. But at a certain point, especially in remodeling, you start cut to fit and making it suit the space. And even in new build construction, we just note, the overall room heights and the locations of windows, etc. And we just apply the same workflow to those areas, and the layout ultimately ends up being what it is. So that's a bit different in this approach where I, measure and show everything. Also in the stringers, and normally on a job site, you'd get everything you needed from the space, and generally speaking, you just build the stringers like that. Of course, you'd make a pair that are matched and install them level, but in this case, I've drawn it right out. I give my the spine, the overall length from here to there. I gave myself this angle here, and then what that leg ought to be. Same with this little length here of this little back thing. And then, of course, he's 90 to there, and obviously each of these are 10 by 7 3/16, which I'll dimension using fractional dimension types, because sometimes I've got a very specific 4 or 5 place decimal, often just 3 or 4 space decimal size, to get this to come out evenly. But of course, I'm not going to do that decimal conversion on the job site. I'll just set the fractional dimensional type, and it'll jump to the most common 1/16 of an inch. In fact, I can play around and get to the nearest 32nd if I wanted, which is not a component to almost anything that I do. So my CAD is set up to jump to the nearest 16th. And so that allows me to use a measuring tape on a job site, and with the kerf and the tolerance of the pencil line and all of that, and the attention that I'm paying to the project, we end up with the right amount of tolerance. So I can make this and count on it to sit down into place. And also, I don't show that in that drawing, but it accounts for the tread thickness. So I did all the design in CAD, and I don't have to play games. I know that the step, and watch me perjure myself here because this is a carryover design from another project, and there are things that get tricky with that, but the step from this surface to the first step surface should be the same as every other step, and it should be essentially the same. I think there's actually a top step that's included with practically coplanar or a little higher than this landing. I don't know what I was thinking with this project. Oh, you know what it is? Because of the tread, because you're going to have a piece of 1.5 inches for a tread. If you weren't to include a step that's planar with this landing, but you were going to call this the first step down, and your first step in the stair that you built is down here, then the stringer becomes too shallow overall. You can't do that. And then you end up stuck like this. Or you end up with this plate, sorry, get back this off. You end up with that plate starting back here in the framing so that you have enough stringer depth to provide for that first step being one down from the landing. Then you end up with a weird little space behind there. There's just some esoteric stuff like that comes with stairs. So if you're looking at this, I did the same thing out here. When you roll that stair up against this landing isn't the first step down and the first step on that. Now that would have been easier to achieve for the first step to be here, and I forget there was probably a good reason that I didn't do it that way. That escapes me. Oh, probably because if I include that first, if I make this step so that it is level with that landing, then at the height that I chose to have the wainscot, rather than this stair section stopping here and being this much shorter, it doesn't translate the wall color happening above the wainscot that was planned. This is actually 3-dimensional beadboard. This was all planned for the finishing the Addams Family set. And so we went around the corner and we kept going up with that wall. So anyway, there wouldn't have been any wall left on the stairs, and I probably did it for that reason, which is choosing to control finishes all the way down to the structure of a component, which is a rare choice, but it's something you'll see in a designer. As a designer, I'll see that, oh, we're not going to return the wall on that, and I'd like to tie that piece into this set piece more. I'd like to see that come around the corner. Sure, I could make the wainscot shorter, but then, see, we're going to something expensive like beadboard. If I get it in a 4x8 sheet, I believe that's milled longitudinally. So if I cut that sheet in half, I get 2 4-foot tall pieces that I'm free to use. Now, if I choose to move that beadboard down below, just lower, then I get into a situation where I got to cut it shorter, and then it's a piece kicking around later that can only ever be that tall. We want to maximize the return on the investment of buying material like that. And in the future, if I want a taller wainscot, I want to be able to do it. Or if I want it to go along a staircase, for it to be the right size and cut, for me to go to a bare minimum height wainscot, but cut a rhombus out of it, then I need the top point of the rhombus and the bottom point of the rhombus to be as large of a piece as possible. So if I make that piece small and then I go cutting a rhombus out of it, I end up with what looks like 2.5, 3 feet of, wainscot when I could have had 3.5 or whatever. All different types of reasons here that we make decisions like that. So I went on a tangent there, but the key thing to remember is that each and every staircase is a little bit different. While it meets building inspection and passes safety inspection for code requirements, you're allowed a certain amount of flexibility in the overall rise and the run. And so stairs don't necessarily all have the same geometry. And I always like to see the first step up from the set or from the stage and the last step at the top, everybody's the same step height. Otherwise you end up with tripping, and because your brain goes into autopilot and it says stairs, okay, we've done 2 or 3 and this is how they all are. And then it saves that processing power for something else. And the minute it hands off that movement that you're making and the stairs change on you, well, then we get a falling up or falling down the stairs scenario that we don't want to see. Certainly not on stage. Don't want anybody to get hurt. And in real life, we want steps to be all the same size. So nothing you probably don't know, but we're going to put extra care into making sure our stringer isn't just a recycled. They save a lot of my stairs here to try and reuse them. Save those, and they'll try to reuse those. And so I want to make a good investment of my time and energy for that reason. All right, let's make a stringer. All right, a couple things here. I knew that I was going to essentially lay this point out first and then work back from there at 54 degrees. That's the angle here. But I use my speed square, and the speed square is set up to tell me, so if I go to 54 on the speed square, which is what I did originally, which is what this line is here. If I go to 54, which is 50, 55, so we're looking for 54, and we're trying to see that right down the side of the lumber. Right? We're going 54 degrees. That's this. Look at 5 is down there. 0, 5, 10. That's this angle. So we're using the speed and we've gone to 54, but the angle that we're putting on the lumber is the rest of 90 degrees, right? If the back of the square is 90. So if this is the angle that we're throwing down there, we're throwing 36 on this lumber right now, not 54. So you got to be careful. If you start using the speed for angles, you got to see what it is you're doing. And I psyched myself out. So I went to 54 and put the line on. Then I went up to this 13 7/8 up that line to there. And then I went at 90 degrees. And I was looking at 90 degrees. I was looking for a step width of, or a run of 10. Each of these runs on the stringer, about exactly 10 inches. So I go from there and I go at 90 and I'm looking for 10, and I was all the way back cutting my way off of the lumber again. And I immediately realized that my angle had been incorrect. So then I go out and I go to 36 on the speed square. If I go to 36 on the speed square, then I get the 54 over here. That's the line that I needed, and then I went to 10. And then another thing that you see me do is I depart this print because I haven't got what I needed, and I set my stair gauges to 10 by 7 3/16, which is what my step is supposed to be. And then I throw that on there. But the thing is, you're dealing with the pencil width, you're dealing with the round on the corner, you're dealing with the pencil not wanting to creep down and actually touch the previous line. So as you come along and try to find this location on the old line, each and every one of those times that you try to start and trace, there's a little bit of error to here, and then there's that error plus a little bit here, and then there's those two little small errors plus the error here. Whether you're going back and forth, whether the error is positive or negative, you're mixing things up there, trying to see, and by the time you've made 1, 2, 3, 4, 5, 6 errors, and you get to here, and then you straighten that line out, that's another error, that's 7, and then you're looking, so I just unlocked that, but I'm looking to confirm that the point from here to here is as it should be, as it should measure on the drawing. And I'm about a 1/4 of an inch long. So if anything, I added as I went. Now the thing that if I wanted to be smart, and I always fail to do this because it's not logical to me, but because I know that this is for the most part how I lay stairs out. One of the most precise things that you can do is give yourself this aligned dimension from tip to, it's going to be the same, but this dimension here, and that's something, like I said, if I had a scale, I could get that dimension, and then I could put, like once I get this corner, then I could put that dimension down the side and use that to control this when I come, and I can adjust based on each, and I could stay on that dimension practically, looking for that line that I put to always be and never work out one to side of the other at that point, and that will control me along to where when I plot this and I check that, there'll be a far closer degree of accuracy in that check. Right, but again, I failed to put it on here, and I don't have the architectural square with me, or the scale with me. I'm not going to wait another day to make these stringers. I know that this is a 1/4 inch heavy, so what I'm going to end up doing here is cutting off my line. I'm going to cut the line off here. I'm going to cut the line off there. I'm going to cut the line. The pencil will go to the waist. Instead, sometimes I keep it to make sure that I've got a real nice square and accurate layout. But if I take the line in every case, I'll end up making it smaller overall. And then if I take it here, you know. In fact, actually, all I could do is, actually, it's a better plan, just to take the line across this cut, or a little more, and take it across this cut, and try to get at least a 16th of an inch to an 1/8 of an inch inside. So that makes my overall length of this thing an 1/8 of an inch shy there, an 1/8 of an inch shy there. And when I come to sit it down into this space, that's actually the most important thing. So I won't be taking the line necessarily on the rest of it. But if I was going to be a 1/4 inch too heavy here, I wouldn't be able to fit. So I'll take an 1/8 off both ends and essentially hope to make that up. Better to be a little bit small and a little bit big, because all of it's going to be covered with Luan anyway in this case of this set. But those are the types of things you want to watch out for. So you're not beating yourself like, what the heck? I put the 54 degrees on here. Why isn't this working? And it's supposed to be this long, and you do this over and over again. Or you even if you're tracing even if you're manipulating that by hand and not relying on these stops, that's far more error being introduced than just using a set of these stair gauges. So just keep an eye out for that stuff. All right, I'm fairly happy with that. And you're looking at that gap going, what the heck is that? But I had a feeling that this 2x4 plate is basically humping up. And it really doesn't matter beyond a certain point here that it may continue downhill and away from a straight line. It's in this region that if it's going up, it's going to lift that whole thing off, and just a degree, it's going to play out over this distance. Obviously, it's nothing here. It's practically nothing here. It starts to become something, and by here, it's several times that, and obviously the farther away you go, the more it diverges. So I can see that not only in the fact that there's light to like there, but also if I pull a string, because a string is going to make a straight line. I've done what I can here to get it right on the surface of the 2x4, pull it tight, and come up here and put it right at the surface of the 2x4 there. But then if you look at that straight string line and you see that 2x4 plate, you can see that we've gained at least 1/4 inch in the middle. And so that is a clear indication to me that that's a lot of what's going on there. And so it's just going to mean that I'll probably unbutton this, unbutton that. Now, yeah, we're controlled here. And that's, you know, you may end up wanting to take these down and stuff. So you want to get this stuff right. In a perfect world, I would have had the stringer decided on and had looked at that prior and everything and put that all onto the framing and then started to skin this thing. So we're going to play a little jazz here because it's going to be these two that need to go away and let that relax and attach the stringer to that 2x4 and then come back with these and just attach them wherever they fall. And that'll be good enough for government work. But this is why order of operations is so important. This whole thing is turned into. I have been the least enthusiastic about this set, if I'm perfectly honest. This is my 10th year, and I've really been waiting for the feeling of really getting motivated and excited about it to hit me. And I've challenged myself with this real wall section and stuff like that, try and get myself motivated, because as an ENTP personality, I don't really like to do the same thing over and over again. And so, like I said, this is a lot of what I've built for a set for a show previously, and on the heels of the whole debacle with my previous project. I've been run down emotionally a little bit from that. It's important to stay motivated, and so and you want to, basically what I'm saying is you want to be aware of what's on your mind and what your goals are and put yourself in the right space, because little things in the early stages can hound you the rest of the project. And so I'm still going to rely on this type of a check and see that I've done myself a little bit of a boo-boo and remediate that now, because it's always well worth in the early stages to make things as perfect as possible, because it just makes finishing things up a pleasure more than a massive headache. And when you're finishing, you're oftentimes feeling the pressure and you're running out of time, or for whatever reason, you want to make life easy for yourself for finishing stages. So we'll make that little change there. We'll go backwards to go forward. Like I say, I've been doing it a lot here. I don't like to look so unprofessional, but this is the place to do it if I have to do it. And it's a good teachable moment, left and right. I'll give you guys, do as I say, not as I do, because these are the problems. I shouldn't have had to have remediate that corner. I shouldn't have had to have added those wheels already. I shouldn't have taken the siding back and forth. I shouldn't have started it on the wrong layout. I shouldn't have to turn this stick around. I took this whole box off to access the outboard screw that holds these sticks over there, and turned it around, and then put this all back down again before I turn this around. So instead of doing all that over again, I am going to just add a 2x4 here, and that'll catch this plywood, and then the other sheet will start on this 2x4, which is not as good as one piece with the coplanar side. The face of this and the face of the other 2x4 can still be a little off and forever control that seam to be a lumpy, bumpy thing. So I'm going to want to put a lot of care and make sure that I get it dialed. In fact, I may attach the plywood to it and then put the other piece of plywood on, and then I just, you see? Do as I say, not as I do. Get things right before you move to the next step. And I'm having an attack of like, okay, I know what I'm doing here. Let's talk about or think about the next thing, just to keep my mind entertained, but in not doing every detail before leaping to the next, which is what the homeowner on my previous project continued to do, is go, oh, well, I got this on lock, what's the next thing? And then he'd be into that, and I got this on lock basically mentally, and then what's the next thing? And he'd have too much in the air for himself. And I try to avoid that professionally, because if you've got too much in the air at the same time, despite the fact that you're going to end up being responsible for doing that stuff in the right order, if you think you're doing yourself a favor and getting it all in the air and chugging it all together, you just run out of bandwidth and you make giant errors, or little errors that turn into giant problems, and it becomes costly. So let that be a lesson to you. Now, because I don't want to, like you wouldn't believe, I'm going to take that stringer off and trace it and make the other one and put it up there and see that I haven't got the same problem on this side first, and then address that issue on both sides. And then when I'm happy with that, we can make ourselves some treads. And then maybe by the end of today, we can go up these stairs and up those stairs. And then when I can walk out on that landing, I'll put the gable end out there. And then I can go up with a ridge, and then I can put the gable ridge in. Wouldn't that be cool to see before the end of today? But you never know what you're going to get to before it's time for rehearsal. All right, back to work. All right, we're not half bad. I did choose to shorten it by a touch, the other one, which fixed a lot of our issues. We've got a similar issue here, having traced that shorter one. But I mean, like, in the scheme of things, guys, this is, you can tell it's the right geometry. And obviously it's all been designed in the computer. And that doesn't just across the board mean it's good. It's been designed in the computer by somebody who knows what they're doing to some extent and has had a lot of experience between the computer and the real life. Things like this will haunt you if you don't have experience with them. So let me set your mind at ease. I did undo those a little bit, and I pulled them back and made sure, you know, that things settled in. I mean, this here is also going to be good enough. I will bother to leave those disconnected until I got everything all put together, but at this point we can make treads. Now, before I left nose, because this two lower stairs came together, it's flush. This is the left-hand side or the stage right side. It's flush. Over here, I hung the tread over because the collateral shadow of that geometry helps these look good up under the lights. And this is what we do when we finish stairs. We have nose on it and it goes around, and you know, further than that, you may have a router pass on that. But that's when these were exposed on the lower and exposed to the upper. Now, I'm not going to expose these stairs. I had not realized that it was my plan because I just pulled the model from that set in, and I had everything, how do I want to put it? This was going to 4 feet wide over 3 feet wide from before, but I went to 47 inches because, like I was saying, I wanted that last inch, or even I wanted to be able to maybe even hang the stringer out from the face of the plywood skin so that there was a natural shadow line there instead of the top edge of the plywood. And then if I did a 1/2 inch out, then I could still have a 1/2 inch of nose on the 48-inch tread, and thereby I could get 2 treads out of every 8-foot stick of lumber. I was thinking ahead. However, I realize now I'm going to probably put another 2x8 right across the face of this and just keep it going right along here as if it's a ceiling joist. And then I'm going to continue this wall up to it. And then we're going to put crown a little cove or something like that to indicate the ceiling. And this will be a finished wall down here, but the face of that 2x8 will be unfinished. And the interior space of that dormer is all going to be unfinished up there. And the back wall, that's the back of the library set, is all going to be unfinished because I want, and these stairs are finished already and stuff, but I want the feeling of once you pass here to be like just Matilda's relegated to the attic. That's her bedroom, is in the little attic dormer. It's probably freezing cold because it won't be insulation and stuff on it. And that's, you know, to make it clear, that's the case. And so this is actually the first floor wall, and this is a stairway that, like, we could keep going down a rabbit hole of like, how does it transition to the attic in this home, whatever. But we're not going to choose to do that here. But I think that's, since that's my plan, then I want the stringer to be flush, and then I want the tread to be flush so the plywood can keep going right across the face of it, just as it'll do here, because our wall that goes up will be actually framed on each one of these steps. Each stick in that wall will go up, and there'll be a plate here and plate across the top landing. But that would mean that we could have gone to 48 inches from here to here instead of 47, because I'd still be able to do a 48-inch tread, and I won't need an overhang. It won't really hurt anything that we took an inch out of the overall width of this thing. In fact, the more that goes by, I may have liked to have come back closer to 36, something more like 40 or 42 inches wide, and save us 1/2 foot down from this. It became a product of trying to get that dormer to work. If you want a window, and this is all unproven, if you want a window opening 20 inches wide, that once you trim it up, and this is underneath the roof, you know, these are the rafters for that right here, but if that's underneath the roof, and that's your window opening, and you want to put trim around that, and that trim is coming close right in this corner, it starts to look incorrect, and you don't have enough siding or whatever we do, the brick or whatever, to the outside of that trim. You can't just have it the width of trim on the front of a gable dormer. That's why sometimes you see that, and it looks super unprofessional to me, because basically nobody thought about it in the context of what size window, and then worked out, and considered the aspect ratios and the white space that would be left in that. But if I could find, for the life of me, one of these views of it, we also want to have enough, a little bit of, you'll see that in the end there'll be a roof surface here, and that, and I wanted enough, again, for what amounts to about 6 inches of roof deck. And so if we go down to 3 feet like this used to be, and then we go in 6 inches, we're at 2 feet, and then we go in another 6 inches on either side minimum, we're at a 1 foot wide window opening, which is absurd. And that's just some rough numbers, but it would likely have been even smaller than that. So because of our window that I hope to put one scene with Matilda and have her sit and look out at, or turn this house set toward the audience and have it make sense in some way, we end up stretching it to 4 feet wide. And we end up concerning everybody with parking it in the back and having room enough for all the kids that are in this show. Or you find out that to leave the cyc in, maybe we looked at this already, but 3 feet will fit behind the next bar that's available, but 4, you can't bring that bar in without shoving this thing into the cyc. Things like that. All kinds of considerations building a set that you want to maintain from the beginning. I'm familiar with the space. This is my 10th year doing the set. So I trip through very few of these things, but I still trip through stuff. And so you want to be aware of any of those considerations. You may be a good carpenter, but there's a lot of other stuff going on here. All right, back to work. Something else to think about now is whether to lug those down and put all the stairs together, or to go to some point where it's a stair assembly and then try to put it back up there. That's going to be a pain in the dick. So I'll probably attach those stringers in a meaningful way to those upper plates and those lower walls. And then I started thinking about, is my riser cover, does that go in front of the stringer geometry, or does that, like these stairs, go back in there? I don't want to go down a rabbit hole of all the different factors here. You need to make sure that when you cut that stringer, if you're not gonna rip a 2x8, and you hope that they're all 1 1/4 or 7 1/4 inches tall, then you want to make sure that when you put them in here and attach them, that they aren't any taller than this. And that's all as a factor of how well you cut everything out for other reasons too. They don't want to hold the tread up, or you start custom ripping your 2x8 to make a riser cover is one annoyance. Taking a hair's breadth off so that it fits but doesn't create a big ugly gap is another freaking problem. So looks to me like I decided to hang those on the inside between the stringers, so then you get the end grain, which in some cases, like in my previous project where I truly built a set of stairs to last for a while, we applied the riser cover to the end grain here, and we ended up with a more professional arrangement. This will pass here because it's not that big of a deal. You won't notice that there's end grain from in the scheme of things. And so those stairs are built from these designs, and I'll do the same thing here. Essentially, I'm going to make, I guess, my risers fit inside the stringer, and then you can just go up until they're flush on top. And regardless of how much hangs down, this is about the height. Then you're going to add the thickness of the tread, which is going to obscure whether or not you're a little short. So it's a safer way to get through that and to spend less time. Although 6 1/2 dozen, which is more professional. Basically, this would be the only way that you would use this as a finished set of stairs, would be as a basement stair. But I like to build them with no overhangs at all, and glued and screwed, and make the geometry that which can be clad with finished or paint grade lumber and stuff later, and just move everything out a little bit, and ultimately you end up with a finished set of stairs that doesn't have to be built custom and then brought in later and installed, which in some cases that's how you do it. You can leave the stairwell empty, and you can have hardwood stairs built to order, and then drywall everything and slide them down in place after the fact, shim them, and then disguise that transition with a little bit of molding. You can build a rough set of stringers in place and stop them short of the framing so that drywall fits in between there. And then you can come back to your rough, your construction grade lumber stringers, just leaving these 2 or 3. Don did this at his flipped house, and these outer ones away from the wall enough to slide the drywall in, like I say. And then the only riser and treads that are installed are the finished grade lumber versions that are 5/4 or greater, so that they've got a good looking thickness and good rigidity. So there's a bunch of different ways to put stairs into a finished construction space. In the case of a set, we're going to do the handiest and quickest thing. So don't necessarily go out and build stairs residential application, just the way that I built them on this set, because it may or may not work for that situation. Lots to do with stairs are their whole thing, and I really like dealing with them and embracing all the different factors, because once you have a working understanding, you can kind of bend that to your whim. I am just running into my own decision making from years ago, and so I'll just trust myself, trust future chassis, trust past chassis. On this one, we'll make our risers first and attach the stringers, and then the last thing we'll do is take a handful, we'll get the other stairs around, we'll put a stack of treads up there, and then just slap the treads down as we go, and then we'll keep her moving. All right, I got this little discrepancy here. To start with, the stack up in this wall and these widths ended up being, I don't actually know which is more correct here, because this landing was built 47 theoretically, and it measures out at 46 and 7/8. So we're missing an 1/8 inch on its overall thickness. And then this is 47 and an 1/8. Meaning we got this 1/4 of an inch here, which is normally not something that I end up with. That's some helper shit. So this plate that I cut for this wall, that's, if anything, a skosh under 40. So if you add 3.5 on both ends of that, you end up with 47. But we've got some gappage here. See, the piece is made correctly, but a little bit of collateral gappage. Next thing you know, you add it all together, you end up with that kind of a problem. This side is a little bit more important. We want it nice and smooth where the stairs land. This side is going to go right on by. There'll be framing above, and if this needs to be basically avoided, if everything's sitting back from this face and we go right on by, and I get the wall that I frame out coplanar with this is what you'll probably see me do, and this can all sit open behind there and no one will care. This may come out more tightly and get there. That gets that 1/4 of an inch almost on its way over. But we've got problems here with, like, this 2x8 was a piece of shit. There's the other part of it up there. It's less cracked, but even showing signs. This is beginning to lift, and this here snapped right off because this 2x12 had some checking problems there. So what do? Well, this one I'm going to take the screw out and just poop out a bunch of construction adhesive up there and just put the piece back overnight. There it is on the floor, actually. That was the problem on that, is there's a knot ended up right on the, and knot ends up right there, and the problem's in the grain density. Boom. Here was checking towards the end of the 2x12, and that just comes from drying. So this one, I'll probably pull that even further to open this up and squirt as much adhesive in there as I can, and then let the screw out so it smushes and leave it to dry, and then come back and re-drill that, or re-screw that. And even while I'm here, I may pump some adhesive in there just as a best practice. So we'll do a lunch. We'll get some adhesive. We're out of 2x8 except for this extra long stick that they sent, which is going to work in our favor because I hadn't planned out for the lumber order to include that faux ceiling joist that comes across the front of that balcony or that attic floor like we talked about, and comes right over here, normal to or aligned with the left-hand side of the staircase. And so that needs to be 134, which leaves me like a foot or less on the end of it. I don't have the 3 2x8 risers that I need in it. So I'll just get 2 8-foot sticks, and I'll get a tube of construction adhesive. I'll come back and we'll get up the stairs to the top. And then I can put that floor down permanently at the top, since I've had flexibility without that fighting me and putting the stairs together. And then we'll see where we go after that. Gotta eat. See, I can't think without food. All right, well, the truth is I'm ready to build the landing end wall today, and I had it set to a ½ an inch off the floor before, but I'm going to bring it up to coplanar with the rest of the lower plate and just scoot the wheels right out underneath it. So as a best practice, they've got the wheels on those triangle pieces of plywood at the outside corner of the construction. Just as a rule of thumb, you never know when something like that is going to be handy. And I can run this out just enough off the front of the stage to get that done, and I'll have plenty of wheels and weight on the stage to keep it from being a problem. The only problem is that all of my sticks are over 86 inches or 96 inches by a long shot. They're going to be out of a 10-footer, and the 10-foot 2x4s I have got, I don't know if it's easy enough to see, probably half the time. It's just fine when I say that when you look at the footage, but this is not an acceptable candidate for wall building. And really the two that I pulled just to have a side, 2 ends for now, and then fill in later when I can get some better ones. He's actually okay. Not in this regard, really. I'm going to try to apply styrofoam to do that brick effect, and the foam is going to be flat, and it's just going to fight us if we haven't got ourselves a nice sort of wall. And this should have never been pulled. This is I might keep this just for a laugh, actually, because of that knot hole. But I'll take this one back. I'll take the other stick back. We got a 2x12 here that we don't need, I guess. We're all done with the big lumber, and it's checked up at the end, like way the hell over into there. And it's just like, this had been the worst, 2x12. It would have been the worst one in the stack 10 years ago. You know, an unacceptable piece, but nowadays this is what they send, and hopefully you can use it because you just feel lazy and don't want to take it back. But we are taking it back. Then I can turn around and get what I need for lumber to do that. So instead, since I have planned with CAD, I know that I can build the rafters. Now I've committed, that was what I was holding off on before. I can do some rafter construction, make these, and the little ones for the dormer. We got the gable end of the dormer up already. It's just that I basically want that wall, and I'm even going to put the post and the ridge board onto 2x4s in that wall. And then the last thing I'll do essentially is take up the rafters and set them together, and then they'll give them something to sit on. I haven't got anything before then. But to maximize the hour I've got today before I got to duck out and go to the lawyer, I will make rafters. So let's get started on those. Just kidding. I've reissued the drawings enough times to not feel confident that the rafter geometry that I've shown is exactly right. So we only have a little bit of time today, and this is how it goes sometimes as a sole proprietor, for me to put my hands right on the work. But I do want to make some kind of headway, and we know that this desk is going to be the fundamental base to a simple piece. It's upside down right now, but we're going to have a rolling wall, basically. On the one side, it'll be this desk and all the monitors and screens for Trunchbull's office, and on the other side, it'll be Honey's house. And the duality of Honey and Trunchbull and the duality of the set piece, I think, is kind of cool. And we don't need these heavy-duty casters necessarily. However, I like to stick to standards. And so I'm just having a look at, like, if I were to put them in here to roll this around, how much would I be out? I really want to be up kind of at this level, at least, but not too much more than that, for about a ½ an inch of a gap. And so there'll be a caster wheel on the bottom of either side of the desk, at least, probably to the front. And then on the bottom 2 outside corners of the wall that it sits against. And it's nice and heavy, and thereby the rolling wall with a desk on it will be quite a smooth operator. However, this is just some 1/4 inch plywood, and I really want to be here. So I think my first move is to make 2 pieces of luan or underlayment that fit just inside of there a touch and glue them in. So then we really got more of a half inch plywood substrate. I think that's a good move. And then after that, maybe I'll do it on the inside too. Add a piece of it. Then you got 3/4 of an inch of plywood. That's probably best case scenario. So I'll probably make 4 pieces, just good enough. It doesn't have to be a perfect fit. So make 4 of these and glue them in today before I go. And then when I come back tomorrow, you'll have 3/4 of an inch plywood, and you'll be at the surface that you want to be at to load this whole set piece up onto to point load it with these casters. Because right now it would just come smashing right through there after a certain point. Or at the worst time when some stage crew person hops up and sits on it like it's a normal desk and breaks it through, and then we've got to make a major repair before we keep moving. So trying to be wise with our time today. We'll break out the old PL Ultra Max. Makes a good glue to use in this situation. You can use wood glue and fart all around, but I'm just going to go this route and know that it's just exactly what I wanted it to be. Sometimes with a lot of surface area, though, it is nice to go back to wood glue. Well, let's get the pieces of luan made, and then we'll see what kind of glue we want to use. All right, I ended up adding 1/4 of an inch, or just under 1/4 of an inch. I can't tell you if these are 5/16 thick or this is only like 3/16 underlayment. I went and identified, because there's a variety of, we've used quote unquote luan or underlayment to skin the set. They used it even before my time. And so there's old stuff floating around, but I wanted something that felt substantial. I don't know that that's got any more layers. Focus. You unbelievable pain in my ass. Where are you here? I'm trying to see the edge of the plywood. Anyway, tried to find something that this feels nice and heavy and rigid, and it's not trying to delaminate when I push on it and squeeze. Some of the other stuff, like the new stuff that we bought, the piece that I originally, the scrap that I got around that came out of the window hole on the set was just, you know, as compared to this, maybe I'll just show you, as compared to trying to bend this but in my hand. This little piece of this weighs about what this piece weighs, and this I can just totally, I don't know if you can hear it, it's just crap. So if we're looking to add strength, I went and bothered to find, I wanted like a piece of birch ply. I thought there was something floating around down there that was a true 1/4 inch thick plywood, but the hole in the stage isn't open, and I ran all the way down to the wood shop to cut it on the table saw, and I didn't want to even pull the full sheet out in the basement and lay out and cut squares with the circular saw, so I'm just feeling lazy because this step is just sort of super preliminary. So that being said, I did my best for what I could find for added thickness, and I got it on both sides with wood glue, which I'm happier than using the PL, which is more expensive and harder to spread out. And then I just used some brads for right now that I'll just cut off later. I don't want to leave them necessarily sticking. Not that anybody's going to put their hand in there. But for now, I ought to hold that together. I'll have to move it out of the way of the rehearsal today. And then tomorrow I can look at putting some wheels on this and maybe build a wall section and put behind it and put wheels underneath all 4 corners and get a rolling wall with a desk base so they can start roughing out the blocking for those scenes. One of the most important things here is to get the bones up and rolling for everything so that the blocking and stuff and the students can be aware of where they're going to come through a doorway and what they're going to have to walk around and deal with long before even stage crew comes out and starts to learn the show and where to move things and when. So that's part of that. I got to get going here by 1:30, so I'm not sure if I can find anything else. We'll just have to see. All right, it looks like that's set up pretty well. I can clip these brads off at some point when I'm ready to get back to doing that. But I've got some lumber now, and I know what I need for that end wall, so I'll treat you to some more time lapse of me running a miter saw and screwing together frames on the floor. But I'd be remiss if we missed a single thing: riveting. Okay, well, I was making really good progress yesterday, and I was going to keep on moving with all the rafters, but I got the two up, and you see me rock it back and forth, and my bird's mouth would sit either on this outside corner or that outside corner, but it appeared as though everything stacked up a half of an inch short, and I wanted another half an inch, and the bird's mouth would sit. But I went back and checked the drawing, and for the rafter, made sure that it measured out as per the drawing. The problem is I made it as per the drawing. And there's some, as a draftsperson, I put dimensions on in places and in aspects that are kind of unhandy to check in real life. So there's a possibility that even though it measures out the way the drawing measures out, the more critical dimensions are off the drawing. I'm going to have to continue. I basically can't figure it out. I went home, so it's the next day since the last segment, and I made a new drawing, but I forgot to print it out. I brought it on a PDF, so I can't actually show it to you while I discuss this. But this whole thing, from the outside surface up there, where the bird's mouth sits, basically bird's mouth to bird's mouth, onto the raw framing that doesn't include this luan, because there's no luan on that, should be 174. So when I walked in here today, I just made sure that to start with down here where I can walk up and measure is 174 to the framing, which I don't know if you noticed, but it is exactly that. Freaking parallax. And then, of course, that could deflect out, or, I mean, half of an inch is an awful lot. And I thought, well, I put this on yesterday, so maybe this wall, I tried pulling it in yesterday to get that half an inch back, but it did not want to come back. It's quite vertical. So then up here, I just went, and these are the checks you have to do, and this is a rare occasion where I haven't, sometimes it just all of a sudden pops into my head what the problem is. But if I go from over there to the top outside here, that's near enough to 174 for government work. And so then I had a dimension. We want to get down to a simple set of dimensions to check. So the simple triangle, it's a right triangle. The bottom surface goes right along this subfloor, regardless of this top step that actually sticks up from there. So it's the theoretical plane of the top surface of this subfloor forever in every direction. The distance from that up the other side of the right triangle to the top surface of this ridge board, because that's where the point of the top of the rafter should go to. And then back down the hypotenuse to that corner, which I don't have for a dimension. But I did extend this plane in the form of to this line onto that stick, and I pulled this dimension to see that is in fact the way the drawing shows. And the drawing is a visual image of a three-dimensional model that works out in the computer, which means it will work out in real life. And the dimension here it's a 16th of an inch short. We're supposed to be 58 inches and 58 inches 1/16. So we're pretty darn good there. And we have the ability to deflect. However, we should be able to put both these bird's mouths in place and set those rafter tips down, and they should be real close to being planar, or, aligned to the top edges of that rim or that ridge board. So I couldn't get that to happen up there, and you're out in space. So the first thing I want to do is come down to the flat surface. So we've got a body line in the covering of the stage that's pretty, fairly certainly straight. When you're setting these sheets and you're trying to keep the gaps consistent, and you work into, something out here. So that's a nice straight line that I didn't have to really create. So, and then there was an intersection. So I stuck a screw there, and I put the inside corner of the bird's mouth on that screw. See? And then we went along this line to 174, and I put another screw at 174. And we've got some angle discrepancies. That's what you'll see. You can see I left a line on the right and I took the line on the left. It's a product of starting the circular saw into a sharp angle and it moving, or the stick moving on the table. So I want to remember that I've got a little bit of error like that, which in a framing situation doesn't matter at all. And so we're close enough, because at 90 degrees to that body line in the stage, I can see that's essentially where I'm at with the angle that's on the rafter tip, and with the plumb cut that's on the end of the rafter out here on the eave. Okay, and in the back of the bird's mouth, everybody's parallel. And so the bird's mouth set to the right dimension. And then, what do we say we want, a 58 and a 16th? So then, this is like the line on the 2x4 up there. I checked that from that body line in the stage over there, I can just hook on it a little bit, I can feel it. Come on, it was doing it before. But I wanted to make sure that the tip of these rafters, or the spine of my big speed square there, is at that 58 and a 16th. So there's the body line and the floor. And so we had here about 58. So about the same as that pencil line. And then, yeah, so spinning about that point in the floor on that screw and taking the rafter tip up to the elevation it should be at, we're almost a perfect 4 inches from one side to the other when we need to have an 1.5 inch rim board in there. So if we need an 1.5 inches out of 4, that leaves us 2.5, and 1/2 of 2.5 is 1.25 inches. So we need to add an 1.25 inches. Not in this length here, not from here to there, because that's a hypotenuse and that'll be greater than what we need. We need to offset this cut an 1.25 inches on all the rafters that we do make to make those work. And rather than using CAD, because I don't have mobile CAD, I've never sprung for a powerful enough laptop or tablet or whatever to bring CAD down here. And during the work week, or during the school week, I can get into the CAD computer lab here and you just use it. So I don't have it today, but I'm gonna do basically what amounts to real life CAD. There's also the straightness of these could be in question, which it isn't. I haven't put a string on it, but I can see well enough that they were the best specimens out of that pile of shit that I got from the original lumber supplier. And so then I went to Lowe's because of their reputation, and probably Home Depot too, they steal everything's #1 up there. If it goes to hell on their watch, well, that's another matter. But what comes in there is normally #1. And the place that I ordered from gets lifts of blend of #1 and #2 quality. And I didn't specify #1 quality on the phone. And apparently that's what you got to do over there, even though I've done business with them for a long time. Frustrating. So this is #1 quality, 4 square sides. And, you know, I made sure they were straight. So this will be what I make the actual rafters out of. These are full-blown duds. And the rest of those 2x6s are going to get taken back. So what I'll do is, I guess, I put these together too as another check. I set them right, and they're perfect copies. Of course, the one I made, and then I traced it and made the other one. So they're perfect copies of one another. They're just both missing that 1.25 inches on the end. And I don't know why the drawing space shows me, because again, I checked these dimensions and it's right in the same drawing based on the same model as the dimensions that I just checked on this entire assembly. I could drill down and measure the rafter that's shown in this assembly, and it measures out the way these rafters measure out. So I don't know what is going on, and I will get to the bottom of it maybe later in the video. For right now, like I say, I'm going to just trace them, move that ridge cut, plumb cut up 1.25 inches, and make that, and make another one, and take them up there, and they ought to hold that stick. Because of course it's distance, it's equidistant. This face of this 2x4 is equidistant from here to this, is the same as from there to there, putting this absolutely on center. The drawing shows it needs a 3/4 inch from this side, from the face of this stair, and we're a little twisted there, but I used essentially 3/4 inch of plywood to put us in the right spot. So if I make those 2 new rafters and I put their ridge cuts flush with the rim board, or the ridge board, I'm sorry, the bird's mouths ought to sit into both locations, and this ought to be at essentially a perfect 90 degrees to this surface. We haven't got something to compare to it out here, but nobody should be stressed out and fighting to be anywhere that they need to be. They ought to just sit right down in place. And so after all that fucking around, I still don't know what the problem is here. I went to the center. I put the one side of that 2x4 and the other side, so this is 1.5 inches apart. I put our center line of those right on there and made sure over the length of that framing square that it was doing a 90 degree up from this point, and went right down the center of those. And that's just missing 1.25 inches on either end. I do not know what the deal is. Anyway, let's just fix it and keep moving. We've lost enough time at this point. Well, that's a lot better than it was. It's still weird. It's pulled me, well, maybe the best way to see that is with a straight edge. So let's see if we can just use the level as a straight edge. Better than a piece of lumber that may be fairly straight, but this is going to be theoretically perfectly straight. If we just set us here, just with regard to this stick, to pull us out and fill the bird's mouth, it pulled us out, it tweaked us out a little bit, 1/4 of an inch over 4 or 5 feet. You know, it's tight, and then it's pulled open here, tight there, and then you can start to see my fingers through there. So, and that's going to be a product of solving this outside the computer without understanding what the problem actually ended up being. Because most of the geometry in these rafters is still what I originally made. So again, I don't have the ability to use the CAD here. Also, when you look at the ridge, they're a little open at the top. That angle's a little bit large. Come on. It could be a touch smaller. That would hold us open, you know? So that would send the bird mouths would sit out a little bit, and being this far away from that, all the further you go, that little tiny misangle influences you more and more. And so we maybe need that 1/4 of an inch close down here as a factor. In fact, I'm fairly certain of this, of that angle being a little open at the top and tight at the bottom. So if I take those down and I mark at the bottom and go to nothing on both of them, then they can sit down without pinching that vertical, and thereby the bird's mouths, when they're tight, it'll let that 2x4 wall come in. I think that we're shoved out to the degree that we are because that's been screwed and gravity's pulling this down and it's pinching and it can't come in any further. So I'll take these down. I think they're going to be close enough to copy, but I'm going to take probably 1/8 of an inch off the bottom and go to nothing, so that about a degree or 2 off of that angle at the top. And hopefully then we'll see what we need. And the question is to go do it to these two and bring them back and put them up here and see if it relieves the tension, and then take them back down and copy them, or take them down just the one time and copy them all out with that small change and hope that that's what we need. So let's see what I'm up for. I'll take you right up here and show you. Once you get in front of it, it's easier to see. So to start with, I just unpinned this, and this is actually more like 1/2 of an inch that I've got to pull this wall out, and it doesn't want to go. So we're looking for 1/2 of an inch, and I think that the reason we haven't got it, it's harder over there, but you can see that this is open at the top and tight at the bottom. So we don't want to change this overall length, we want to change this angle. So we want to go from taking nothing away to usually a modification like this. You want to copy this distance to the best of your ability down here and go from that to nothing. And thereby this whole thing will sit 1/8 of an inch tighter and sit down another degree, and a degree out there will make for quite a bit of distance. All the longer and farther away we get from where we're pivoting, to move a degree, you know, if we went a mile in that direction with this stick, and to move 1 degree up here, we'd move hundreds of feet when we do that out there. We just need to move, you know, 1/4 of an inch, because we'll do the same thing on this side, which is struggling from the same thing out there. Open at the top, I can feel it, there it is, and tighter at the bottom. So we'll do the same thing, and then we'll sit down and close a 1/4 of an inch over here, and then everything will, between the two sides, will make up that 1/2 of an inch. And hopefully when we put those back together at the top, this will be sitting here and it won't have this tension on it. And this will be a learning exercise. And this is why you want to make sure that your first rafter that you're going to trace and make all of them is exactly right. because if it were the other way around and we needed, I don't want to complicate matters here, but if it was open here and tight at the top and we wanted to close that or something, we can't add wood back essentially. So we're in good shape here because we can take a little bit more and hopefully these will be usable pieces to us. So this is the type of thing you want to have an eye out for, even though this is rough framing and stuff. Want to get that just so, and then once we're tracing it, we're cutting on that line as perfectly as possible and not excusing ourselves. If you notice, I clamped my wood down so it didn't shift and just change my angle of attack a little bit. These are too long. I want to get a cut hub which would support my lumber out to 8 or 10 feet on both sides of my miter saw. And then I would do these, I would set the angle on the miter saw and I'd cut at least 3 or 4 of them together every time. And that is a handier way to make a rafter that, as long as you're content with it, instead of circular saw cutting all of them. It's a mark of professionalism if you can circular saw cut them all. I'm doing that because they're too long and there's no way I can support that lumber here without making a whole shebang to do it. And I don't feel like that. I'm just really struggling. So to, keep momentum, we'll take them down, we'll modify, and I'm fairly certain that'll fix our issue. So then I'll bring them back up and check probably, and then I'll go back around and do the best practice and then make the rest of them. So let's keep moving. Okay, I'm content with that, but I don't know where I miscounted. If we use 4 on this side, that leaves us 2 over here. I guess that's all right. We've got the outermost rafter that's flush with the framing on both ends of this thing. But then for a dormer, you come over and you stick one to the outside of either of the sides of the gable end wall. And there's a variety of ways to do this, but I need to frame that triangular wall that is the side of the dormer, and it needs to sit on something, and so it would not sit on the surface of the roof. It would sit inside of that. We're gonna fake things out a little bit here. Whether or not we, trip through that. Whether or not I frame this little wall and leave it, whether I put nothing in there or a stud layout in there. So I don't know if we're gonna block any action in there. And if I were to put brick on that, it would tie it in visually with the outside of the house and look kind of cool. But I wouldn't do it with so much foam thickness like I plan on the end wall. We'd just use the same little 1/2-inch thick brick application, faux brick face pieces, and stick them to like Luan or something, because we don't need to appreciate the thickness of that. in any way, the way that we would need to appreciate the thickness of the brick on this cross-sectional wall. And so, but then it's opaque, you know, and so like I say, I don't know if we want action there. And so I'm gonna hold off on that. I'm also looking at this trim. See, the main curtain is out here. This component and the main curtain that opens and closes. We can't take that up any higher because then you start pulling a bigger gap underneath it, which isn't cool. But as you can see, this component here of trim is 1 bar in from the main curtain, and that's what's brushing. I'll go up right up there. It's brushing the framing. I have a piece of 2x6 here to illustrate. So the issue is, now I could sneak that up a couple inches to clear, because if we want to push this piece out beyond the trim to feature Matilda in this window, if we do this, we don't want to brush into that. So I could take this up a couple inches to clear, but the reality is that this still needs a 2x6 rafter. I don't know how best to illustrate this, if that's even the correct angle. It might be. It's close, yeah. So anyway, the rafter and then the deck, the 1/2-inch plywood I was going to put on there and then put fake shingles on it. You know, we have to come up 8 or 10 inches to feel comfortable about clearing that. And then all of a sudden the sight line from the seats past this to like more bars and lights become undesirable. That's the point of this thing, to being adjustable. So what I think I'm going to do is I'm going to take this amount out. I'm going to shorten these sticks and slap the bottom of this back on, drop this thing down, so when the rafters go on it, they're just there, you know, and then I can bring that up an inch or two. Or perhaps I'll just cut it down short enough to miss everything here by an inch, which would be nice. It makes the headroom, because to go along with these rafters, there's the ridge board, just like there's this ridge board, and that comes along here to somewhere, and that justifies the absolute overall height in this dormer that Matilda's got to crawl along. And if she sits here, I'd like to get this vertical out of here once we get the front rafters and stuff up to this board, take this vertical out so this is at least open, and she could sit on this step or something and be featured. But I don't want it to be impossible for her to crawl along and, you know, maneuver and look relatively elegant in getting situated to sit in that window or look out that window or whatever. I want to afford us these options if I can keep these options, but I have a physical problem here with that. So I'll probably take 6-7 inches at least out of the overall height of that, bringing the ridge of that down, etc. I can't put it back, so I want to make absolutely sure that I don't want to just sneak that trim up. So there's a bunch of factors here that I should talk to some of the other production people and make sure that all things considered we're doing the right thing. This is quite big and tall as far as everybody's concerned on the show. I often push the boundaries of what people think are reasonable. Normally everybody's happy in the end. Where I started with this was when we built this for Adams, and I keep talking about that, but this is only 1/2 of what we had. We had an entire mirror image half and double doors. French doors went in the center, and it was enormous. But really, when you put it on the stage and put action in it, it didn't look as big as it really was. This is going to be a few feet taller and it'll look like a full house on the stage, but since we only made 1/2 of that set, I've felt fairly comfortable in bulking this up quite a lot, because it's nowhere near as much volume as having the other half of it, you know, from a previous show would have been. So I've gotten pretty large and in charge with this. It's a whole foot deeper than the other one was. This lower stair just, you know, unattaches from this to take them in either wing to get them out of the way or to flatten them. So hopefully that doesn't, you know, become an issue. And again, earlier in the video I said this was 4 feet wide, because that leaves me just enough to put a 2-foot wide window opening here, which gets smaller when you make it look like there's actually a window in it. And then the dormer again needed to have enough roof and then siding and then window trim, and then the opening needed to be big enough to do anything with it if we can, and thereby we didn't make this thing thicker. So again, just trying to maintain an appreciation for all the factors before we paint ourselves into a corner. I'm also considering taking this little frame out, because of course this is the ceiling height. Normally the floor joists or the ceiling rafters in a home, that's where the drywall ceiling is finished across. And that would just mean that this thing could come back out of here, this could come out of here, and we just slap blue on up there. And it just, I don't know why the ceiling would be lower in here. I brought that down because this rolling door was that height. And that was what we did with Adam's. The rolling door that snuck underneath there was a loose piece. But in the case of this set, this is attached to that. And so if I want, I can just have some framing, carry some glue on it, that surface up to the ceiling, and then cover the ceiling. And I think we're gonna maybe look better. I'm not sure yet. I think so. Because it'll be, once we paint the trim on this door, it'll be such a little amount of wall, and there's no reason for this to be that big and bulky. You know, the other thing was, if it wasn't going to always have something underneath it, just that landing, especially loaded from above, hanging out into space here on this footprint over here, would have been probably really having a hard time and trying to deflect. So this assembly gives that more rigidity as a cantilever, but we don't need that now. We're stacked permanently on this column corner and this wheels out here, and that's all underneath that 2x8 landing. So now this is far less structural and more just superfluous. So I'm entertaining that notion, and I certainly built it in a way where it could come right back apart again, although those screws at the top will have to be just cut off with a carbide blade for now, but I think that's worth it. And we'll probably leave the 2x4. No, we wouldn't leave the 2x4 plate at all. So yeah, so I could take like that screw, and there isn't even another one in there. I'd have to cut that right there. I can never get this thing to be what I want it. I have to cut this horizontal 2x4 right on that seam, and then take that out of there, which I probably end up doing that once we're further along with the whole scenario. I'd like to get the other front rafter on, and then I could take that front vertical out, and then put the other two rafters in on either side of that gable, take the gable down, shorten it, put it back, and then maybe make the ridge from that gable to the block that goes between those rafters to hold the other end of it, and see where we are after that. So let's see what's... Well, I'm starting to feel it, but unfortunately, I started this project and tried to see if we rebuilt this old set, if there'd be room enough for a dormer where the ridge is lower by a foot or so than the main ridge, because if you have the dormer run into the ridge of this house, it changes kind of architecturally the style of it. It might work okay, and these are things that would physically work, but visually start to get away from what I'd like to see. And so I took this ridge to just a hair under 14 feet because the trees we built for Shrek and everything else we've ever made for this space has been under the limit of 14 feet, and we haven't got a problem with any of the overhead stuff. But this year, we've got this projector, and we're gonna be doing quite a bit of background projection on the cyc as a screen at the back. And now I don't understand. I've already asked if it could be taken higher. I'm told it can't. I'm told this bar can't go up We're almost under it here. If we went an inch up or two, you know, even if it pulled the projection an inch or two off the floor, that's not necessarily the end of the world. But to go 8 or 10 inches to get this Snorkus Magorkus, I don't know what this periscope that obviously turns the projection around the other way, why that was necessary. I don't know if coming from back here, if you turn this unit around, it moves the projector that much closer to the screen and creates some kind of issue that I'm unaware of. I don't know. I looked this unit up and it doesn't show this, so this must be an additional thing. I don't know if it just turns the projection around or allows it to go wider or taller or anything else like that. Unsure. You know, and my other thought is we could take the bar up and then tip this thing up with the U-bolts and even, you know, do something more to make sure that you know, jump between the cables, and I don't know. Anyway, tip it. But then I don't know if the keystoning or the squareness of the projection, once you turn it up, if it pushes the edges in, and if it can't be keystoned to close to vertical again, then you've got that problem happening with the projection. And so it looks like there's a lot of things going on. We got multiple things plugged in. We got safety, and obviously I'm not going to mess with any of this. I'm sure there's a good reason for the way that this is. However, if we can't do anything about it and it's a super hard no, which I won't be able to know tomorrow, it'll be Monday before I can even ask what we can do, if anybody will work with me on it. But that would mean we've got to make this ridge, bring this ridge down a foot, which changes the angle. And I'm going to have to redraw this in CAD and regenerate the rafters from scratch. Maybe then if I make them exactly according to the CAD, they'll work again. But I'll try to, and I'll have to make them so that these physical pieces of lumber can be altered to be a rafter for a lower roof line. And then I've already come down enough with this dormer to the point where I was concerned. So if I have to lower it further to look visually relative to this new ridge, then you really get into a situation here where it's difficult to navigate this. Besides, you know, I don't know if they mind her on her hands and knees. And these are the things that I don't have an easy time communicating with some of the other members of the production crew staff, not because they're not open-minded, but because it's hard to visualize what I'm talking about. But I can't make that landing any lower. It affects the stairs. It affects how they work to these pre-built stairs. And so we're stuck with this all the way to there. And so the only thing that I can do is bring the roof angle down. But as soon as you get away from this roof angle and you start bringing it in lower, the house really starts to look a turd, and you have to bring the ridge of the dormer, and it just starts squeezing you in multiple ways. So I guess I'm done packing it this week, and I'll probably come tomorrow and work, but I'll probably put the wheels on that desk. I'll have to bring some wheels down, and I got to build a wall section to go behind it. So I guess my focus tomorrow is to get a wall section attached to the desk, and that wall up and rolling. And then I've got a small fireplace that I picked off the side of the road to put on the other side of that wall. So I suppose that'll get Honey's house and Trunchbull's like office layer up and rolling, which is not a bad thing to do on the weekend, so that Monday's rehearsal, they've got that set piece at least. And we'll just have to find out what we can do about that projector. I think it's a terrible idea to lose a foot of headroom overall for the sake of that projection. You know, I like to build sets, and I don't necessarily love projected elements as a backdrop. I like the floor row or the colors on the psych and stuff like that for sky and different things that we've done, but fully projecting onto the back, it should have been a rear projection. Front projection, I mean, it is filling to the floor from here, and so by height, as we move nearer, as we move upstage and closer to the screen, we start throwing heavy shadows on that screen, which can be appreciated from the far sides of the house, but not in the middle. It starts to mess with stuff. I don't know that using the projector in a musical, I mean, they can use it for presentations and to go along with the band and orchestra and stuff, but in my mind, it's not such a marvelous thing to where we leave our headroom lower by a foot now forevermore in terms of what sets we can build. And it seems like, oh, just make the set a bit shorter. You can't put people up on it then. You can't, you know, things get cramped. It has a collateral effect, essentially. And so I was always real happy with the 14 feet, and I'm kind of sticking to it. We'll see what happens with that. I guess next segment, we'll just get started on that desk tomorrow. Well, we're down here at the storage unit where those trees, whatever happened to those trees, Chazzy? Here they are. I don't know what it laid on there, but the unfortunate thing about them is that being deformed in here as the temperature swings, that's going to be frozen like that until I do something about it. Same with these are of the largest ones were deformed already from just laying around. It's just hard to put them anywhere where they, where that won't happen. And now the top of this other one has been deformed all year long with the weight of this one. I didn't have a better option at the time. It's just tough. This is the largest space that I could afford, and I couldn't even really afford it. So it's been $70 some a month now for almost a year to store these. And moving them around, the problem is that the paper's fragile and will only ever get more fragile. Although the more we paint it with good quality exterior paint, acrylic based or urethane, and that'll actually work more like a resin, not to make it hard or like bulletproof by any means, but it would add structural integrity. So I like the idea of these getting repainted a few more times. I don't know, I'd like to get some more mileage out of them. I've needed the wheels back off of them, which is why we're here today. I'd like to bring the two medium-sized, 1 and 2 out, and maybe one small, but I'm going to finish taking these two wheels off, so I'll take this medium, the small underneath it, and that medium. They're trees 360 degrees, and they're trees 360 degrees, and they're easier to manage than these giant ones that have this white, like they're trees one side, and then they're this like stone column on the other side. If you didn't see that series that I built, where I built Shrek the Musical last year. I'd like to go outside at Cruncham Hall, and I'd like to use these trees to do that in the schoolyard or whatever. It would make up for the fact that they've been laying here being unproductive this whole time. So we're gonna probably roll up here and load 2 or 3 of them out tomorrow or the next day. But for now, I gotta get a couple more wheels so I can get that Cruncham desk up and rolling with the wall behind it. So let's pull these. I'm not gonna run any time lapse on this. We'll just get this thing. Well, I'll admit that these holes adjacent to the cake pans that held the caster wheels were designed to be able to load weight. That's what this little piece of metal, if you go back and watch that series, I was going to load rope weight vertically in here, go up, tip out, and set into that trough, that metal piece, to hold these things, give them a heavier base and a lower center of gravity. It didn't end up becoming necessary, this added weight of the plywood and just the geometry, the distance from the surface of this tube to the outside, or to the point that the wheel's on. Just the triangle of points where the center of the caster wheel touches the floor was a large enough triangle with this added weight to make these extremely difficult to tip over. You have to genuinely put your foot, certainly the larger ones, as a 2-man operation almost to tip it over, and the small ones you really have to work to do it, which was awesome. So that being said, they also work excellent to reach around in here, give the old reach around and undo or hold the nuts with a wrench, 9/16 wrench, 9/16 socket. I didn't even need that much of an extension really, and I only put 2 in each just because it was going to be overkill to put 4 nuts, bolts, washers, all brand new nylock into that project. So I was happy with how they performed with just the two to take the wheels back off. Now we got the 50 some, 60 some, 70 some, I don't know anymore, dollar each Rose brand caster off these pieces, and we can go put them on the other pieces. Meanwhile, the trees that we want to use down here and over there still got the wheels on them. And hey, we've even got some hardware that looks like it might bolt up, 3/4 inch plywood. Well, no, we may need to go with something a little bit longer, but we'll I don't know. Here are all the others from the wheels I've already stolen here. Maybe I'll bring those with as a best practice. So the cake project that I ended up doing, and that worked out great, starts by cutting this paper pattern. I use the old, I think it's I forget his name, but he's on YouTube and makes a lot of sheet metal parts, and you can often either roll the form or a pattern around on a flat plate and trace the sizes they lay down like that, or you can roll things that roll like a cone or a tapered cylinder like this. And so that creates a pattern
of the surface that's rough enough, certainly for this application. You can get real precise with that, or you can do it in the computer, yada yada. But I got some of this fabric around, and I'm working with the fluffy side down, which is something some people may not realize is handy. When it's longer hair, it makes it really handy to cut just the back and sort of keep from giving it a haircut by accident. But this is like a seal skin, like a really short fuzz on it. But I knew that there was a lot of potential there to style that and make it look like it would catch the light in the way that frosting that's been spatulated would catch it, hopefully. It could be styled with gel or white glue, or in the end, I was considering a clear caulk silicone or polyurethane, so that it could be, like, if I didn't know yet what we would use to make his face all brown and chocolatey, so I thought, well, if it gets all over this thing, then we'll have a problem. It could be washable. So I did some tests that I don't ultimately show on video, but the idea of impregnating or coating the fabric was also on my mind. And I ended up making a different end for this cake. I think I got my sides, because you're going to put things together like you'd sew them facing inside to do your seam work, and then turn it around like a sock, and you'd have a finished thing on the outside. But I ended up, I think, with the first end either facing in the wrong direction or the fitment was bad. But I remade it, and I put it together partially on the form, partially in my lap or on the bench or whatever you want to call it. And I got something that I was happy with and pulled it off. At that point, you could hand whip stitch that, sew it on a machine. I just haven't got the ability to walk up and sew in the shop, and I just wanted to see this. I knew there was going to be a lot of fiddle work in the way that I attached the fabric to the plastic, because of course the genesis of the idea was this collapsing bucket. I thought about those wire collapsing hampers, and then a smaller version, maybe like a camp sack, that would flatten, but it didn't want to stay down in stages. The foam idea that I had initially was still too voluminous to allow the magnets to stick it flat. So I ended up firstly with an Ozark Trail Walmart square. You may see it in the background, collapsing bucket for like camping, a camp sink, I think it is. It's a squarish collapsing camp sink, and it would work just fine if you have a square look cake in your head. It's not as tall as this bucket, but it would be remarkably different. This I wanted it to be just really decadent and like truffle-like, and I ended up with the berries and stuff on top. But so it starts with that plastic bucket, and I periodically needed to mechanically fasten to that. You can't really easily hot glue to it in a way that won't strip that fabric off with the type of cycling it was going to get. And so I went with these grommets. They're going to be, Joann Fabrics or someplace like that, where you cut a hole, and it's just the type of thing that you have in the edge of a tarp to cinch it down. Different types of clothing sometimes will employ it's a toroid. It's a donut. But it's cut in half. You put the one on one side, the one on the other, and in forming them together, they curl around and meet and support the circular hole in the fabric. You grab and hold it, locate it, and finish inside and out in that way. They give you that little mandrel aluminum thing to back it up, but that works fine when you can work on a flat. But I needed to be up and inside this cake, so I had to haul the stupid anvil around and yada yada. It has a nice place out in the breezeway, but this project's always happening in February, so I'm not hanging out in the breezeway. And then I needed a corresponding hole in that fabric, and being a polyester, or let's just call it a synthetic, a plastic fabric, I was able to heat a nail with the torch and just press it through. I started by cutting, but really the torch melted hole has like a hard plastic edge, and if you do it right, you get a sense of what you're trying to accomplish, and you get the grommet to fit up with it. And I think we ended up with a really nice attachment of fabric to plastic. And I went to the plastic, not the rubber, which is the part that deforms. And then I got this stuff too, close in color as I could get. I had hoped to find a chocolate brown, but this is pretty darn good. And it ends up giving the sense of a different fit, the same color, but a different finish from afar. So even though it's not really the same color, it looks like spatulated frosting on the cake, and then this looks like piped edging, from, again, with all the tassel and fringe and all that stuff at Joann's. I believe I got this too, so I just got myself. The first piece I did as a test, and what I thought were the last pieces, I figured I'd do them together because I ended up with sticky glue on my cardboard, and then it didn't want to put the new ones back onto that and have a problem getting them back off. So I did try here to do the rest of what I thought I was going to need all together on one piece of cardboard. I powdered the other side. That's what you watched me do. First I thought I'd do that and just work on that, but I figured then there'd be powder on the thing, so I just powdered it so it could be turned over without being sticky. And I made sure to compress. I thought this thing was going to be a prototype and that I could work this quickly and try stuff like that and take risks with glue sticking or not sticking and just sort of learn. And then I had another bucket that we didn't ever use. This worked just fine. See, because I'm hot gluing straight to the bucket here, like I told you. I couldn't do. Now, that part really isn't rubbed back and forth the way the layers pass back and forth, which is why I think I got away with that for now. And I thought you better do something at the bottom, so I was going to maybe play it from the bottom edge up, but I think I ended up just hanging it down. And I thought I was going to do that right here. Right, so, and then here we are back on the same cardboard that I thought I wasn't going to need to get near the glue again, but I did. And then I put it on the way I wanted to see it, but then I thought, man, it'd be nice if that wrapped under or over the edge of whatever's on the bottom. So let's take it back off quick. I'm the biggest advocate for like clearing your space off, making room, thinking things through, fully planning, yada yada, and then once in a while, especially on the musical, sometimes it's better to just get to work. And I did like a scarf. I just tapered the edge on this, thinking that that would be a little more like it would run into this edge and blend out. But in fact, I should have cut the circle smaller and then done that. I should have taken another ½ inch off the outside. So essentially, I tried gluing it up and around, thinking that would be good. And ultimately just, I think, trimmed it back with the scissors, but that's fine. And then I went and applied that edging, which I guess I didn't get any footage. And did a quick layout. I guess there were 8 vertical rows of holes around that I laid out, and they ended up working out to the 8 locations where I wanted to put berries. And that was a factor of looking at it from a low 3/4 to either side. And 6 works fine, but they're just, you lose 1 or 2, and then it only looks like 3 or 4 on top of the whole cake from essentially what the angles, all the angles in the house of the theater. So the more berries, the better.
All right, one last thing we got to do is make these fake little cherries or berries stick onto the cake. And if you notice a few things here, I sealed the bottom of it up with some thin EVA foam, and I put this sort of fake frosting down and around the corner of that as well. I ended up doing them out of order to start with, so you see me switch that and get this first and then get this trim like glued over around and down onto that. And then I put some short cabinet screws, little short wood screws, which stick through the plastic right there. I'm going to put some Great Stuff foam, just a quick bead around in there. So in reforming this and pushing it back up for rehearsing and stuff, you're not stabbing your finger on the other end of these little screws. But it was a real nice way of putting the 8 points that I chose to have for these berries to stick to with little magnets, which will be more than enough. But how to get... To start with, we got some little 1/4 inch diameter by 1/16 inch thick magnets, and we got to glue those to these pom-poms, and the pom-poms are mostly fluff on the outside. So I chose to use a little butane torch, and I just sort of toasted a little bit, very briefly, each one of these, and I just kind of snuffed and smudged, and I ended up with a harder plastic sort of flat surface that they want to sit facing down on. And now all I got to do is glue each magnet to that. But the handier thing to do is I got this is the tray for the whole thing anyway. Any piece of steel that's ferrous enough. This is stainless, but it's still magnetic. I'm being careful of how I serve myself these magnets off of the stack. So I'll pull 4 off and lie them down in the same orientation. Then I'll pull 4 more off and turn them upside down and lay them down. And I've got some wax paper here. The point is, when we're all done, I'll have 2 sets of 4 magnets and 2 sets of 4 magnetic berries that want to stick to one another, which I think is a handy way to be able to keep track of them. They'll also stick to this pan, which is good. And so I think over the course of this thing, I'm going to take the extras down and we'll have them around in case we lose one. Same with the magnets, but hopefully we don't need any of that. So I'm going to serve off 4 and then turn them over and serve 4 more off, stick them down to the wax paper, and then I can put a blob of hot glue on each and push the flat side of this pom-pom down and essentially encapsulate the top and the side edges of the magnet all the way around with hot glue and marry that hot glue to this rough plastic surface on the pom-pom. And with the wax paper, I shouldn't be gluing them down to anything else. It may be better to use parchment paper. There's some other, you can use some thin silicone gasket material, anything that wouldn't let the glue stick to it. So we'll see how the wax paper works. But the idea is the same. And there's nothing about it being a similar sort of layout as the top of the cake other than just keeping them away from one another so they're not jumping across and sticking to one another. And again, this was useful because it was already ferrous and the magnet would stick to it. And see, we end up with what amounts to a magnet that's sort of flush and it's sort of embedded in some glue. And so if we treat it right, it won't hurt if we get a little wax paper because it'll keep things from wanting to stick together. So they are sticking to the wax paper a little bit, but it's not the end of the world. It's not actually bonded, it's just sort of the very slightest bit. And that's going to vary with the temperature of your hot glue gun, but I'm fairly satisfied with that. The little trail, that's the one thing with hot glue, it always leaves that little trail off where things, the string is still connected. But overall, for a first pass, I've got plenty of, I've got plenty more pom-poms if I want to play around with the exact recipe here, but we can stick them right on and they want to stay, which is the desired effect. They come right off because, of course, over the course of eating this thing, and they don't need to be set on stage. They can be set by props. As long as they want to stay there and not roll away. And you also don't want a shear strength. I didn't want to be trying to pull them off there. It has such a strong magnet that I'm fighting with the glue. It's absolutely glued better to the pom-pom, the magnet is, than the magnet sticks to the head of that screw, which is the point. And then as we eat this thing, they can come off and they'll, essentially should find one another as pairs and sort of ultimately stick together like that. Here we go. We got 2 groups of 3 and a single pair. So anyway, it's working for the most part along the lines of what I wanted it to do. Oh, those are opposing. No, there you go. And so they don't get lost, right? And ultimately, this whole thing, they smush. So we're getting there.